Welcome to AI Tech Time. Today we will cover deep learning. Let's start. What is deep learning? Deep learning is part of a broader family of machine learning methods, which is based on artificial neural networks with representation learning. The adjective deep in deep learning refers to the use of multiple layers in the network. Methods used can be either supervised, semi-supervised or unsupervised. The key steps involved in deep learning are as follows. 1. Data collection. Gathering a large and relevant dataset is crucial for training deep learning models effectively. 2. Data preprocessing. Cleaning, normalizing, and transforming the data to ensure it is in a suitable format for training. 3. Model architecture. Designing the neural network architecture, including the number of layers, type of layers, and activation functions. 4. Model compilation. Selecting the loss function, optimizer, and evaluation metrics for the model. 5. Training. Iteratively feeding the data into the model, adjusting the weights through backpropagation to minimize errors. 6. Validation. Evaluating the model's performance on a separate dataset to avoid overfitting. 7. Hyperparameter tuning. Optimizing hyperparameters like learning rate, batch size, and number of neurons to improve model performance. 8. Testing. Assessing the model's performance on a completely unseen test dataset. 9. Deployment. Integrating the trained model into real-world applications for making predictions or decisions. 10. Monitoring and maintenance. Continuously monitoring the model's performance and updating it as needed to ensure it stays relevant and accurate over time. Defining neural networks. A neural network is structured like the human brain and consists of artificial neurons, also known as nodes. These nodes are stacked next to each other in 3 layers: the input layer, the hidden layers, the output layer. Data provides each node with information in the form of inputs. The node multiplies the inputs with random weights, calculates them, and adds a bias. Finally, nonlinear functions, also known as activation functions, are applied to determine which neuron to fire. Top 10 algorithms used in deep learning. Deep learning relies on several fundamental algorithms and techniques that play crucial roles in building and training neural networks. Here are the top 10 algorithms used in deep learning. 1. Gradient descent. The cornerstone optimization algorithm used to update the parameters of neural networks in the direction that minimizes the loss function during training. 2. Stochastic gradient descent (SGD), a variant of gradient descent that randomly samples a subset, mini-batch, of training data at each iteration, making it computationally more efficient and often leading to faster convergence. 3. Backpropagation, an algorithm for computing the gradients of the loss function with respect to the model's parameters. It efficiently propagates errors backward through the neural network to update the weights during training. 4. ADAM, adaptive moment estimation, an adaptive learning rate optimization algorithm that combines the benefits of both Aadhaar Grad and RMS Prop. It dynamically adjusts learning rates for different model parameters. 5. Convolutional neural networks, CNNs, specialized neural networks designed for processing grid-like data, such as images and videos. CNNs use convolutional layers with learnable filters to detect spatial patterns. 6. Recurrent neural networks, RNNs, neural networks designed to handle sequential data, such as time series or natural language. RNNs have recurrent connections that allow information to persist across time steps. 7. Long short-term memory, LSTM, a variant of RNNs that addresses the vanishing gradient problem and can capture long-range dependencies in sequential data. 8. Dropout, a regularization technique that randomly sets a fraction of the neurons to 0 during each training iteration. It helps prevent overfitting and promotes generalization. 9. Batch normalization, a technique that normalizes the activations of neurons in a layer, making the training process more stable and accelerating convergence. 10. Autoencoders, neural networks used for unsupervised learning to reconstruct the input data and learn useful representations in the process. They consist of an encoder and a decoder. These algorithms are widely used in deep learning research and applications, enabling breakthroughs in computer vision, natural language processing, speech recognition, and many other domains. While there are other important algorithms and variations, the ones listed above form the foundation of deep learning methodologies. Researchers and practitioners continually refine and innovate upon these algorithms to push the boundaries of what is achievable with deep learning models. I hope now you are more clear about the deep learning. With next coming video, we will start the topic natural language processing. Please subscribe my channel. Thank you.